Hey guys, today we're going to be looking at the three states of matter that we're most familiar with. So this would be solids, liquids, and gases. And there are two things you have to keep in mind when we start. First, atoms are always moving. They never ever stop. And how fast they're moving depends on temperature. So the higher the temperature, the faster they're moving. So that's the first thing. Atoms are always moving. Second thing you have to consider is the fact that atoms are just a little bit sticky, so they'll have a tendency to stick to each other just a touch. And let's go ahead and start looking at the simulation now. Here we see a solid. We can see that these atoms are moving. They're kind of wiggling back and forth, and they're stuck to each other. So like if we watch any particular atom, it's stuck to a certain set of neighbors and won't change what neighbors it's stuck to. And just a quirk of the simulation, sometimes you'll see one like this one might flop over a little bit. But in an actual solid, these atoms are completely stuck to their neighbors and they can't go anywhere. This causes a solid to have a definite shape. So here you can see it's like a cube, and for a solid that's a cube, it will stay a cube as long as it's a solid. Also, because those atoms can't really move other than to shake back and forth, solids keep the same volume the entire time. So now let's add some heat energy to this. So let's increase the temperature, and remember that will cause the atoms to move faster, and that will turn our substance into a liquid. And so I've just set the simulation to show that once it's a liquid, these atoms are now moving faster, and they still stick together a little bit, but not quite as much as in a solid. Now they can switch neighbors. So you can see if you watch one atom, it will bounce around and be stuck to any number of different atoms, and it will move from place to place. This is what caused liquids. If you think about it like liquid water and you pour it out over a counter, it's going to flow over the counter. The reason for that is that the atoms, they still stick together, but they can move past one another. This causes a liquid to take the shape of whatever container it's in. But because they still stick together just a little bit, liquids have a definite volume. So the volume of this liquid will never change. It always takes up the same amount of space, but its shape can constantly change. Finally, if we start to speed this up some more, so if we add even more energy to these atoms, we can get what's called a gas. And in the gas phase, these atoms are moving so fast that they no longer stick to each other at all. When they hit, they just bounce directly off each other. So they're moving very fast. And since they're not stuck together at all, gases don't have a definite shape and they don't have a definite volume. They will fill whatever container you put it in. So the volume of a gas is just equal to the volume of whatever container you put it in. So let's look one last quick thing. Let's talk about density. Because in all three of these situations, there's the same number of atoms in there. But notice how the volume changes. The smallest volume is going to be with the solid, and with a liquid it spreads out a little bit because they're moving fast enough to kind of move around, and then with a gas they spread out as much as possible. In general, it's not true all the time. Water is an exception, but in general the solid phase of matter is going to be the most dense, and then the liquid is a little less dense than that, and then the gas phase is the least dense of all of the phases. So again, that's not true all the time, but most of the time that is true.